Thank you so much, Jan. You're right. It's indeed a privilege to be talking in front of such esteemed audience, I should say. Right. Thank you so much for that. So, in the next, let's say, 8 to 9 minutes, what I want to take you through is what does digital twin mean for us? Why does digital twin become such an important aspect of one's, factory, or let's say the entire institution for that matter? And then how can one perceive digital twin in their organizations, right? So for us to understand what digital twin is all about, we need to first understand why would one need a digital twin in the first place, right? And for that, I want you to go into a world of imagination, right? I have a couple of slides to show. And as and when I move across these slides, I would want you to imagine yourself in those situations, right? So imagine these large wind turbines, or let's say windmills, which are there at large geographical areas of mountains. Imagine these windmills which are in the middle of high seas, right? Imagine how difficult it is to go and change a small part within this entire huge structure. Imagine this paper mill which spans right from the fender to the roller section with hundreds and hundreds of parts, moving parts, non-moving parts, critical parts, and whatnot, right? Look at this reciprocating compressor. Yeah, so this churns out oil in the middle of an oil well. Yeah, any stoppage of this would really be detrimental for the entire process flow. Now imagine this kilometers long conveyor belts, which takes your ore from right where it is mined to the factories where it is really churned out, right? Imagine this cement kiln, the complex process which is there inside the cement kiln, which helps you to produce these cement, which you pack and then build your houses, industries, whatever. Look at this large reactor in a chemical industry, right? Complex reactions within these different reactors, hundreds of temperature variations, hundreds of chemical aspects that you need to take care of to have the right product out, right? Look at these large turbines, both steam and gas-based turbines. These are the heart of lot of the energy-producing units within your large industries. And finally, look at this ball mill. Yeah, so this helps you in crushing ores, different kinds of ores. It could be alumina, it could be rock solid ores and whatnot. Now, what do you think all of these assets have very much in common? Right? And if you just give it a thought, you see that they are large and huge, for sure, right? By the nature of it, it's totally spanning across kilometers in some cases, right? It's really complicated. If you see those reactors, if you see those machines, they're really, really complicated. They have a high capex and opex. To run these machines, you need to burn a hole in your pocket. Now, what happens when they break down? Yeah, it most invariably brings your entire operations down. And more often than not, they usually operate in very hazardous environments, even where you cannot go and take a temperature reading, right? Let's say, imagine a hot sulfuric acid bed beneath you in a chemical factory, right? Would you dare go and take a temperature reading over there? And then it is, you saw those windmills, how difficult it is to access. Let's say even if you want to go and change a small screw or a small bearing, which is there at, let's say, 150, 200 meters up in the air, the bearing might be peanuts in terms of cost. But going and then, changing that, it's really a task, right? And then it's spread across various geographies, right? If you see that conveyor belt, right? We have an example where the conveyor belt is of 230 kilometers, right? And imagine the number of motors that would be there in that conveyor belt. And imagine 5 of those motors conking off every day, right? Your entire year is filled with job, right? And then what will all of this present to you is, in one way or the other, they bring you a lot of uncertainties in your day-to-day activities. And then, with these uncertainties not being answered or questioned, it turns into untamed complexities. Yeah? And that's when we lack a lot of transparency in our entire operations. Yeah? And this leads to something called as invisible inefficiencies. Yeah? And what do they really affect? The bottom line and the company's P&L, yeah, at the end of the day. Now, what you need to do to keep these assets up and running is to be able to monitor them 24/7. Yeah? And more importantly, what you need to do is to be able to predict the problems before they arrive, right? And that helps you to keep them in the most optimal way of working or the most efficient way of working. Now, if you sit back and imagine, right? If you go and ask these industry persons, or let's say the people who have been on the field, on the ground, day in and day out, all of these scenarios is something that they can relate to with a wink of an eye, right? And one important thing that we are trying to probably overlook is how are we affecting the lives of people who have been working in such kind of scenarios, right? When I go and talk to the heads of the maintenance and then the CDOs and then the CTOs of these organizations, they say, one day, if I'm able to sleep the entire night without being worried about my assets getting bad, that would be, the most happiest thing that I could imagine, right? And with now things changing faster than ever, we need to be very, very, agile in the way how we would want to attack and then solve all of these problems. Now, how do you go about doing this? Is by a solution called digital twin. Yeah. Now, there has been a lot of buzz around the term digital twin, and then there are a lot of definitions of what this digital twin is all about, right? If you ask me from, let's say, a technical aspect to define digital twin, I would say it's a dynamic software model of a critical asset that relies on sensors and instrumentation data to understand its state, respond to changes, and help you to take better business decisions. Yeah, real complex, right? Let's step back a bit and try to understand what this digital twin means in the terms of a layman, right? Now, look at this asset. Yeah, it's a simple engine, let's say, and then you have a lot of aspects, dynamic aspects, static aspects that are invariably related to this physical asset. Now, imagine an exact replica of this in the digital space. Yeah, it mimics every aspect of this asset in the digital space. Now, how do we do this? Is by mimicking and then sticking on to the basics of engineering, like the basics of physics, the basics of mechanics, basics of mathematics, to understand how this asset is performing based on the inputs that you get from the physical space, right? So while building a digital twin, you look at 4 pillars. How do you understand the state? How do you get this understanding onto the digital space? How do you make sense out of it? And then how do you present it to the customers, right? So we were just talking about actionable insights, right, just before. Yeah, and that's what is very important, as one of the gentlemen rightly mentioned there, right? I don't need to know, like, the temperature of the bearing is going more than 100 degrees. Now, what do I do, right? Do I continue? Do I stop? Do I go for a maintenance, right? And all of this, in a way, relates to the environment, right? Relates to the efficiency, and then thereby a thread is always connected to how efficiently we can run these machines, thereby contributing to the nature as well, right? And digital twin helps you do that. Yeah, it's an exact living replica of your critical asset that helps you to predict what is there in future for it, and then helps you to drive it in the most efficient and and drive it without any problems per se. right? And that's what digital twin we build comprises of. Quickly moving on, I think I'm already out of time. We talk of 4 different types of digital twins: a product twin, an application twin, system twin, and a process twin. These are different types of twins that cater to different industries. End of day, we look at efficiency, we look at how good you can operate this asset both optimally in terms of cost, in terms of efficiency, and thereby helping to address a lot of different things that a customer wants to, right from sustainability to green carbon footprint to achieving more revenues out of it, and number of things that they would want to achieve, right? With this, I just finished my short talk on digital twin, and thank you for patient listening.